everybody. Myself Palkumar Pathak. What if I ask you that you are given a number which is only made up of 6 and 9s and you need to just change at most one digit to make the largest number possible from the given number? Welcome to the Lead Code Problem Solving series. Today we are going to solve the exact same problem 1323 maximum 69 number. We will start by understanding what the problem is trying to say, then start with the most brute force approach, and then move to the most optimized solution for solving this problem. So let's just start by understanding what our problem is trying to say. So let's just start by taking an example. We are given an input number which will contain a number which will made of only 6 and 9s, and our task is simple. We need to return a largest possible number made from this number only, and we only have permission to change at most one digit only. Either we can't change this anything and we just return the same exact given number, input number, or we just change a single digit that we are having in our input number. Okay, that is our simple task. As you can see, if we change this 6 to 9, okay, then we have this number. Okay, and if we change this 6 to 9, then we have this number. Similarly, after changing each and every 9 to 6 and after changing each and every 6 to 9, we will have this set of numbers, and from these numbers, as you can see, this is the largest number, so we'll just return that. This is our simple task that we need to do in this question. Okay, so let's now move forward by getting for the most brute force straightforward approach. Okay, so let's just think what we can do for solving this problem. So we are given the input in the form of a single number. Okay, as you know, we need to change a single digit. For working with single digits, we will need to reach each and every digit of the number, and for that we can't directly work on the given input integer. Okay, because you know that for working on single internal digits of a number, we can't just directly use the given input number. So what we'll start by doing is that we will first extract each and every digit from the given input number and then store it in a hash based structure or any other data structure for our easiness, so that we can reach each and every digit internally. Okay, so let's just not think anything forward and let's just do that first. For doing that, we will need a temporary variable, because obviously we can't just edit the original given number, because we will need it for checking in forward code. So let's just take a temporary variable which will contain our original number. Then we'll be using the same traditional method to extract the digits and store it in our hash based structure. And also the hash based structure that we'll be using, it will be vector, because we are working with integers, and vector is one of the best hash based structure for working with integers, because it contains many methods like push back, push front, and etc. many others. So let's just name it as store. Okay, currently it will be empty, and what we'll do is that we'll first extract the digits, and side by side we will store it in our variable called store. Okay, so this while loop that we'll be using for storing the digits, it will run till our number is greater than 0, because it is the traditional method of storing extracting and storing digits from a given number. So we will simply do is that we will use a digi named variable which will contain the single digit of our given number, that storing part will start by iterating from the last digit. Okay, because it is the traditional method that we use normally, that we start by the last digit of our number, then we store it in our single digit, then we store it in our variable or hash based structure where we want to store it, and then we just completely remove it by dividing it the original number by 10. That is the simple method that we use. So let's just do the simple thing, that exact thing here. We will push back the digit that we have. Okay, and then as I mentioned, we will divide the number that we are using by 10. By doing this, using this while loop, now we will have thus each and every digit of given input number inside store. Okay, so now we have each and every digit. We can use every digit one by one by using the store named vector. Okay, we have done that. Now let's say, think forward that what we can do by using this store, that we can easily solve this complete problem brute forcely. So after getting each and every digit of the number, what we can do is that, as you know, our task is simple, that we can just change a single digit of the given number to get the largest possible number. Okay, so you will be seeing in the problem that we can change 6 to 9 and 9 to 6, both type of operations we can do. But obviously it's a common sense that for getting maximum number, we will obviously change 9 to 6, because it's just degrading the value. If we change 9 to 6, we are just decreasing the value, which is not our task. Our task is that we need to return the maximum number possible. And for that, we obviously can't, we won't do 9 to 6. We won't change 9 to 6. So let's just not keep this in mind, 9 to 6. And we will just keep in mind that if there will be a digit called 6, then we will just change it to 9. Okay. Now, what process we will do to solve the problem is, if we get 6, we will just change it to 9. After doing that, we will completely rebuild the number from scratch inside the loop or inside the part which we will be using for iteration. Okay, we'll change the 6 to 9. Second process, we will rebuild the complete number after changing. And then we'll just check that if the number that we have rebuilt, if it's greater than the current number or the original number, then just store it in a single variable. And if it's not greater, then just move forward to the next digit of the store. Okay, this is the simple process that we'll be doing. I hope you understand what I'm trying to say. So, as I mentioned, let's start by iterating to each and every digit of the store. Okay. After doing that, here it's okay. So after doing that, iterating from start to end, as I mentioned, we'll do is that if the current number, the digit that we are on, if it's equal to 6, then just change it completely to 9. Okay, change it to completely 9. And after doing that, as I mentioned, we will just rebuild the number completely from the scratch. Okay, for rebuilding the number, we will do exactly the opposite of the part that we are doing here. Okay, we will take a temporary variable called, let's say, extra num. Okay, which we will initialize as 0. Okay, and for rebuilding number, I am going to use the mathematical operation where we just studied this complete part when we were kids, that a number can be divided into units, tens and hundreds, that type of digits. And we will be using that same mathematical concept here also, that we will rebuild the number from scratch from last digit of the store to first digit by multiplying it one by 10. Okay, and as we have initialized it with 0, so for the last digit, it will be that last digit into 0 plus let me just show you by writing the code. Okay, as I mentioned, internally we will iterate through the complete store again, and then what we'll do is that we will use that mathematical concept, that the current value of extra num into 10, which is currently it's 0, so 0 into 10 is 0, plus the last digit of the store num. Again, there is a mistake that for iterate using the last digit, we need to iterate from the last digit to first digit, and here I was iterating from the first digit, so let's just change that part. Here we'll iterate from the last digit to the first digit. Okay, I'm just going from the last digit to the first digit of the complete store. Okay, and then after doing that, we will just add that digit. Let me give an example that for example, in store, how will this digit will be stored? This number, it will be stored as stored in this way, 9 comma 6 comma 6 comma 9. So we'll start by iterating from this last digit, okay, this 9, and currently the extra num will be 0, so 0 into 10 will be 0 plus 9, so extra num will have, okay, moving to the next iteration, which will be 6. So 9 into 10, which will be 90 plus 6. So it will have 6. Okay, that way we will rebuild the complete number from scratch. Okay, this way we can just do exactly the thing what we want. Okay, so this way we will have the complete number rebuilt from end to the start completely. Okay, and after that what we'll just do is that we will check if the rebuilded number it is greater than the current number, then just store it, otherwise move forward. So for checking we will need another variable, and again I think you would have noticed that we have this temporary variable just sitting like idle because its actual use completed after completion of this loop. So let's just reuse it again in this for loop too. We will just redeclare this as num for checking, and here we will just check if the extra num that we have rebuilt from scratch, if it's greater than the temp, then just store it in the temp. Okay, then just store it. That's our simple task. We will just check if it's greater, then just store, otherwise just move forward. So by doing this, we are just solving the exact complete task that we were given. That if it's given 6, then just change it to 9 and just rebuild the number and check. If it's greater, then just move forward. Then just store and then move forward. Otherwise, just directly move forward. I just forgot one single thing, that after checking and completing all the processes that we are having, we just need to rechange the part from 6 to 9 to 9 to 6, because we are going to rebuild the number. So we will need the exact original digits that we were having for the previous numbers. So we will just revert back the change that we did here. Okay, I hope you understood what I'm trying to say. We will need all the original digits. Okay, so the change that we did, we just needed to revert it back for checking forward digits too. Okay, this way we can just completely do our task that we are given. Let's just check if this works for our problem or not. Let's just check it for this complete statement. I have just run the test case, all the given test case, initial test cases for the problem. So yeah, it works. Let's just submit the given solution and let's just check if all the test cases internally the problem works or not. So yeah, all of them works too. So as you can see, this was the complete brute force approach solving this problem properly. Now, as you can see, it passes the 100% time complexity. Obviously, because it's because of the network. Okay, it happens many times in lead code, but you can see the space complexity is not that much good, because obviously we are using too much variables during the complete process, and we are using nested loops too. So the time complexity will also be order of n square. So this solution is obviously not optimized. Let's just get to the most optimized solution for this problem. Okay, let's just remove this complete part and let's just think how we can optimize the solution that we have for this complete problem. So what we were doing is that we were extracting the digits, then we were just going through each and every digit one by one, and we were checking if it's 6, then convert it to 9, rebuild the digit, compare with the original digit, original number, and then return if it's maximum or not. Okay, this was the complete process in a complete recap part that we are doing in the brute force part. Now for reducing this to optimize part, what we can start by doing is that that if we have this number in the form of integer, we can't work on it. But what if we convert this number into a string? Then we can easily iterate through each and every character, but in the form of digits. We will see it as digits. However, we will be iterating in the form of characters only, because string has characters. So we will convert the digit given number to string, and then we will treat each and every character in the string as digits. Okay, let's just do that first. Let's declare a string s, where we will have two string of the given number. Okay, here it will be capital, yeah, to string of the given number, so that we can iterate through each and every character, and the complete while loop that we will be using, the traditional method of converting a number to digits and storing it one by one, it will be reduced properly. Now what we can do by using this string is that instead of getting each and every digit, iterating through that each and every digit and rebuilding the number and just comparing, what we can do is, we know that if it will 6, then we will be just needing it to convert it to 9. Okay, you know that the first 6 coming in the number, most of the times in 99.99 cases, if we convert the first coming 6 to 9, it will be a maximum possible number only. Let me give an example too. See, you know that in this number 9669, the first 6 coming from the start of the number is this one, and you know that by converting this 6 to 9, we are getting the most largest number possible from this number. And I guarantee you that you can try it by yourself also. In all the possible numbers made through 9 and 6 only, the first coming 6, if you change it to 9, then it will convert itself to the most largest number possible from that given number. So we know, and by knowing this thing, we just don't need to rebuild the number by checking each and every digit and then comparing it. That complete large process will be just converted into a simple if condition, okay, which will be doing it here itself. Let me show you in code how we can do that. So we'll start by iterating through the complete string. Okay, s.size. Okay, and after doing the iteration from starting to end, if the character that we are on, if it's equal to 6 in the form of characters, if it's equal to 6, then just change it to 9. Simple and sorted. Okay, if it's 6, then just change it to 9. Okay, and after doing that, just break the loop, because we don't need to iterate through another part of the string, the left string. Okay, you know that if we get to this 6, and after changing this 6 to 9, we just don't need to do anything with this left string. Okay, the left parts of the given number, but for this code, the left string, we just don't need to do anything. We don't have any work with this string, so we'll just break the loop after changing first 6 to 9. We will just break the loop. Okay, and after doing that, we have our work completed, but we can't directly return because it's string, and we need to return in the form of integer. So what we'll do is, we will just use another method present in C++, which is stoi, string to integer, stoi, string to integer, and we will pass our integer that we have, the string that we have, which is s. We will just pass that string, and let's just check if this works as an optimized part or not. Oh, really sorry. There was a syntax error. I'm really sorry for that. I just forgot. Also, I forgot this thing. Maybe, oh yeah, this is also an error. I need to we need to break inside the if statement only. Otherwise, it will just break in the first iteration only. Really sorry for that mistakes. I just forgot in the nervousness for this video. Let's just check if it works for the test cases. So yeah, now it works perfectly. Let me just submit the complete solution to the optimized. Yeah, as you can see, the complete optimized solution also works perfectly for solving this problem. So this were both the approaches for solving this complete problem, maximum 69 number. As you can see, we can just decrease the complex processes that we are doing by just thinking the optimized part in the unoptimal way, that how we can solve this problem. So this were the complete solutions for the part. If you like the video, how I explained and how I solved the lead code problems, you can just like the video and subscribe to my channel for more these type of tech and coding related concepts and problems. Also, if you want to connect with me personally, then you can use my social connection link present in the description of the video. If you want the source code, then you can also get that from my description of the video. The GitHub link is given there. Thank you very much for watching the video. Thank you.